if we combine the numerator into one single fraction, and then invert and multiply by the denominator combined into one single fraction. So what would be the LCD if we were combining just the numerator? We need an x and we need a 5, so there's our LCD. We take 1 times the missing LCD factor from this denominator, which is 5, minus 1 times the missing LCD factor from this, which is x. Okay, so again, what we're doing here is find the LCD 5x, take 1 times the missing LCD factor here 5, minus 1 times the missing LCD factor in this denominator x. So we've created one single fraction here. We can do the same thing in the denominator. Here though our LCD is 25 and x squared. So we take 1 times the missing LCD factor, 25, minus 1 times the missing LCD factor here, which was the x squared. So in looking at these, if I were to factor this completely, I'm going to remove a negative and reorder my terms. So the 5 becomes a negative 5, the negative x becomes a positive x, and I just switch the order of these terms. If I do the same thing in my denominator here, I can factor out a negative first, becomes a negative 25 written second, and an x squared written first. And so the last thing to do here is to factor my numerator even further. The difference of squares factors into x plus 5, x minus 5 over 25x squared. And so now the final step here is, instead of dividing, we're going to invert and multiply. So the 25x squared gets moved to the top. The negative x plus 5, x minus 5 moves to the denominator. And now you're going to multiply through this set. So when I multiply, here the negatives cancel, the x minus 5s cancel, 5 goes into 25 5 times, x goes into x squared, leaving the 1x. So across the top, we have a 5x. Across the bottom, we have the factor x plus 5. So there's your solution. When you look at domain restrictions, you see that you canceled factors here and here. And so you know that x can't be a 0, x can't be a 5, so you have to identify those extra restrictions. And now again, to be consistent, remember since we inverted and multiplied, all factors in the top and the bottom of this fraction have to have domain restrictions accounted for. So you see that x can't be a 0, that's already shown. We already identified that in our domain restriction. Okay. All right, let me show you an alternate way to solve this. Okay. And it's based on the fact that if you can recognize you have 1 over x minus 1 over 5, and then this denominator is the difference of two squares, right? This is the base 1 over x squared, and this is the base what squared? 1 over 5 gives you 1 over 25 when you square it. So you could just factor it right away. You could say that this factors into the sum and difference of the terms. The terms are 1 over x and 1 over 5. So the factors are the sum and the difference, which allows you right away to cancel those whole quantities as factors. If you did it this way, you would still need to combine everything here in the denominator into one fraction. So our LCD is 5x. We get 5 plus x. And now when we invert it and multiply, we just flip this denominator, the 5x. Here's your fraction in the denominator. 5x gets moved up. The x plus 5 gets moved to the bottom. If this is the case, you would still need to go in, though, and make sure you identify any domain restrictions. And so this is where you want to make sure you're very careful if you're going to do an alternate method, that you can still go in and find where your domain restrictions lie.